So now we have to talk about inertia. Not inertia as in proving the formula of inertia, but applying inertia to various forms of objects. Like for example, the box circle which we have talked about before. But now we are going to move into other advanced stuff. So now we know that the inertia of the box whose base is B and the depth is D is equals to BD cube over 12. That is the inertia of the box. So what if we have a hole in the box? That is a box like this, whereby we have this. Now the base is B, that is from here to here. We have this depth D. No, let's put this capital letter B and this will be capital letter D. Why this is small d and small b. The moment of inertia, the moment of inertia of this right here is b d cube over 12. That is the capital letter b d cube over 12 minus the small letter of b d cube over 12. That is equals to, you put 12 b d cube minus b small b the cube. So that is for an hollow rectangle. And you can also apply the same format for a circle also. You can also apply the same format for a circle, given that we have a circle that is hollow at the center, whereby this is the radius, and we have d as the big diameter, then we have d small d as the small diameter of the inner circle. The moment of inertia of the x-axis is equals to pi d raised to power 4 all over 64 minus pi d, that is the small letter d, raised to power 4 all over 64, which is equals to pi over 64 open bracket d raised to power 4 big D minus small d raised to power 4. So now this here is the moment of inertia of an hollow object, and you can apply it to other objects, but most of the time it's mostly applied to circles and maybe rectangles. So now after this, we might also be asked to find for the moment of inertia of two different shapes joined together, which for example mostly a T-section. Now let's take a look at a T-section whereby we have something like this and something like this, given that this is A1 and this is A2, that is the area of 1 and the area of 2. This is the base of the first one and the depth of first one. We have the base, the depth of the second, the base of the second, the base of the first, and the depth of the first. So the moment of inertia of the x-axis is given by b1 d1 cube over 12 here plus b a, which is the area of the first one, times y, and now y is given as not y bar, y bar square, that's what it's given as, and y bar is given as a1 y1 plus a2 y2 all over y. That is the formula all over the area, all over a1 plus a2, that is the total area. So now that is the formula for y bar, which is the centroidal distance. So that is the formula b1 d1 cube over 12 plus a1 a1 y bar square then plus b2 b2 d2 cube over 12 plus a2 y bar square. Now that is the formula for a T section, and if it is also like an H section whereby you have an extra a third one, you are just going to apply it, which is b1. You have b1 d1 cube over 12 plus a1 y bar square. You have b2 d2 cube over 12 plus a2 y bar square, and you are also going to put, if there is a third one there, you can put b3 d3 cube over 12 plus a3 y bar square. That is how you go on about that moment of inertia.